Hello everyone. Today our topic is encoder and decoder. Let's start with an example. Suppose you have to send 8 bit of data from Bangladesh to USA. And let's assume 1 bit will take 1 second to send. So 8 bit will take around 8 seconds to send from Bangladesh to USA. But what if you have a system over here that can minimize this data and send it to USA, and in the USA you have another system that can decode or replicate the same data over here? Then what will happen? Suppose you have 8 bit to send, and this system can convert that 8 bit to 3 bit. So now it will take around 3 seconds to send it to USA, and in USA this 3 bit actually converted to the same 8 bit pattern. So now we can save almost 5 seconds to sending a data from Bangladesh to USA. So this is we can say A system, this is B system. Let's talk about another example. We use keyboard in our daily life. So you have a keyboard over here, and if you see in keyboard we have many unique buttons, right? But this keyboard is connected with a PC or CPU. We connected this using some USB connection, or if you see some old keyboard, you can see that PS2 connection is available over there. So there is multiple actually data, but we are seeing only in PS2 we have seen only 7 or 8 lines, and USB we have only 2 lines. So what is going on inside that keyboard? So inside keyboard each button will create an unique data, right? Suppose you are pressing over here A, and it will carry some kind of binary data, and that data actually is encoding inside the keyboard and sending through that line, and inside the PC there is another system that actually decoding that data and representing as a inside a PC. So this system is called encoder, and this system is called decoder. So what is the purpose of this encoder and decoder? So the decoder and the encoder circuit is to convert from one type of input data, input encoding, to a different output encoding. So we can convert this 8 bit to 3 bit and send it to a decoder, and that decoder will convert the same 3 bit to a same 8 bit pattern. Suppose we have, let's talk about 4 bit. So 1 0 1 0, this actually sending from a encoder. If we have 4 bit, so this 4 bit is sending, and for 4 bit we need only 2 line. So from 4 is sending to a 2 line, and then we need a 2 to 4 decoder to replicate the same data. So 1 0 1 0, and suppose it is converting as 1 0 over here. So we are sending 1 0 over here, and you will get the same 1 0 1 0 over here. How it's done, we will see it in the later video. So this is actually the purpose of encoder and decoder. So we can say that if we have a 2 to the power n inputs, and if we use here as a 2 to the power n to n binary encoder, then we will have n outputs. Okay, and to see the same data at the user end, so we need over here n inputs, and here we need n to 2 to the power n binary decoder. So here we will get 2 to the power n outputs. So this is actually the basic of encoder and decoders, and in your throughout your engineering life you will face lots of encoder and decoder. So some encoder are called priority encoder, and you will have some 7 segment, we called it 7 segment decoder. You will have hex encoder, and so on. So each of the encoder and decoder comes with a pair, so they have, each of the encoder have some unique kinds of encoding system and also unique kind of decoding system. And please remember that to decode the same data at the user end, so you have to use the same kind of encoder that is used to encode that data. So if you have 8 to 3 encoding system in your transmitter end, so you have to use the same 3 to 8 decoder at the receiver end. So this is very important to remember. So that's all from the basic parts of encoder and decoder. So in the next part we will talk about the priority encoder. Thank you.